This is a basic walkthrough of the components of a project I'm working on called hydrothermic engine. Basically what it is an engine that's going to take heat differences and turn it into energy. What you're looking at here is a kinetic actuator. This is a coil that will be filled with acetone and heated and cooled as rapidly as I possibly can with a pump and valve system. Now, as this coil is heated and cooled, the pressures that we'll get will be around 1,000 psi's depending on the bore stroke that I allow on this volumetric flow booster. Basically what we have here is the flow booster. It's also the pump, the hydraulic pump. What I've done is taken a jack apart, $14 jack, and inverted it. This is the small piston that usually provides the pressure that pushes on this piston that lifts up your car. But I've taken the piston out and it will be connected to this piece here, which is attached to the cylinder. The cylinder will then be slid inside of that, and this is just a return spring because atmospheric pressure is not high enough to reset this thing by itself, so it has to have a return spring so that it will turn back and pump fluid, because basically these check valves in the front here will pump fluid in through here and then push it out that way. And the way we'll be doing that is with this piston, this connector, and this heating coil will be connected as you see there. And this kinetic actuator will be contained inside a housing, an annular housing, so that we'll have a hollow space in here for engine components. And I'm going to take a stack of these. I'm going to try and start with a stack of 4 kinetic actuators and see if I can make an engine that produces enough hydraulic flow to drive a power steering motor that I will then connect to an alternator. Now, when I did a volumetric test on this coil to see how much fluid it would actually contain, it was more than this jar, believe it or not. So I'm going to redo the test and get a more accurate measurement on how much it will contain. But I believe this test stand here contains about 150 milliliters. I can't remember. I have the specifications written down somewhere. I'll get back to you on that. But with this device here, on this little tiny piston, with just regular tap water, hot tap water, I was able to get a piston stroke of that distance with a pressure of 500 psi's. Now, the water temperature was on the order of about 130 Celsius maybe. Let me see here. Sorry, I'm not ready for this. Okay. These are some of the parameters I started to see. I didn't have much time to do all the testing, but yes, I was getting 500 psi's off of 125 Fahrenheit water. And what I'm going to attempt to do here is connect this volumetric flow booster up to this piston here, and I'm going to set some weights on top of it like this, and there will be a hydraulic line going from the top here to the top of this, and then that will lift up and down, and we're going to see how much weight we get off the secondary booster. I could do all this mathematically, but I want to see it happen. Sometimes a visual demonstration is a little bit better than something on paper. And in this apparatus here, basically what we have is the ability to check the expansion and pressure parameters of different fluids. I've got a little vial here that has been destroyed by isopropyl alcohol. For whatever reason, this kind of plastic will suffer somewhat of a hydrogen embrittlement. What did I just do there? I don't know if you can see that, those cracks. One time I dumped freezing cold isopropyl alcohol into one of these syringes, and it shattered it immediately. Cracks spidered all up and down this thing. So that's something to take note of with isopropyl alcohol, 99% pure. And basically what happens when I have this valve closed and I dump hot water through this, it flows through this heat exchange, which basically consists of a head plate just like this with that many copper tubes going through it. And you see the secondary bulkhead attached here. Water is flowing through the coils, and the space in between the coils and inside this tube is the kinetic actuating fluid. So basically when this valve is closed and I fill this up with oil and have a tube coming from here down to here, we'll be able to do some tests and see how much pressure this little piston can provide. Now you cannot press this down with your hands when it's at 500 psi's. You can press it up against the counter and get your body weight to actuate it. To add to the subject, these are some of the equations that inspired the plausibility of this application and some of the figures I came up with. With 100 psi temperature difference, I'm able to attain 10,140 psi's inside of this device. Now I did not do that. I actually only got it up to, I think it was 700 psi's. I'll have to look into that, or I may have gotten it up to 2,000. It's been a while since I've done experiments on this, and I've got so many things going on at once that the numbers just kind of get jumbled. But this is what we're looking at. I know you can't read this fast, but if you pause it, you might be able to see some of this stuff. Okay, here we go. I was right. 750 psi was achieved with a header leak. This device, the first time I built it, was soldered together with silver solder. Silver solder is very tricky stuff to use sometimes. I had some dirty parts or something in an area that I thought was soldered and it was not, so I had a hairline crack. And if I were to pressure this thing up to 120 psi's with a Schrader valve and put it in my sink, you could see bubbles coming out of it. So I had to take this thing completely apart, take both these heads off and resolder everything. So even after an inspection, I did an inspection on it, and sure enough there was still a hairline crack. So definitely a good idea to pressure test anything with air before you go putting it into service on stuff like that, because I learned the hard way.